Thank you. Um, so, uh, Yesterday there was a lot of discussion on um, sort of where our large challenges are in California for emissions reductions, both GHG and NOx, and one of the presenters threw up a slide of showing that it's just a California program. So, a little bit off topic, but this is the same slide for the current standard for ozone attainment across the U.S. with the 2015 70 ppb standard, and California appears to stretch all the way to the East Coast on this particular map. So we see that going forward there are going to be challenges for more than just us on the West Coast, but there'll be challenges in the mountain states and here in the Great Lakes region in the Northeast. So the improvements we're looking to achieve through our in-use programs and our emission standards should be useful to some of the communities further east of us. So in my talk on here, I want to talk a little bit about some of the things we've done with PEMS in off-road, developing some experience with that. Talk a little bit about where we see there may be some possible improvements for how people are looking at their calibrations and which parts of the calibration that the focus is on, and then talk a little bit about some future directions we may be going with on-road testing or off-road testing and compliance. So, Dan had this beautiful large bulldozer. These are some 2-engine earth movers that we did some retrofit work on. Clearly, we were retrofitting the rear one. But we've, over the last 10 years or so, we've been administering money through the MSRC funding source and also from settlement agreements, and working on putting PM retrofits on off-road equipment. And so, it's given us experience where we're very familiar with the kinds of things that were said earlier about these being, difficult environments with high vibration and keeping the testing equipment going and whatnot. Here's a picture of one of those with one of our PEMS units on it. One of the things we've noticed is that there's the slide earlier with showing the different engine map regions where the activity for the one engine going into all these different applications, but we see a fairly large amount of variability just even in a given piece of equipment that was temperature profiled for a retrofit application and looked good, and you put it on there, and then the application shifts or it changes ownership and that shifts. So job site to job site can have quite a bit of a challenge in the off-road. And we saw that some of the active systems were much had more ability to respond to those kind of changes, where there's a little more intelligence in those retrofit systems. As was mentioned, that it is quite a harsh environment, and it's hard on both the equipment and those trying to test it. We did see quite a bit of benefit from these vehicles. We were out trying to keep track of what they were doing and how well they were performing. So we had some telematic devices on them, and then we were doing periodic downloads of the retrofit controllers and whatnot. And having access to that data stream on a regular basis enabled us to identify when a certain piece of equipment was having trouble, whether that was some kind of oil consumption issue or something had broken or something that to address. And so we see that there's probably benefit to moving to improving the amount of diagnostic information available in the off-road space. And so just exactly how and on what schedule to do that remains to be defined, but we see a lot of value in our other programs in having diagnostic systems and having them available to the operator. And in the diversity of applications in off-road, a lot of times there's some sort of semi-unattended operation. There's separation between where the engine is mounted and where the operator is sitting. So there's a lot of sort of equipment integration issues of getting that information to where someone would notice it and be able to act on it. And the advances in telematics are probably helping address some of that for the fleets. But that's an area that we think is really important to helping people understand what's happening to their equipment and be able to act on that. I wanted to say a couple of words on, when we're certifying engines, we tend to require the worst case be evaluated, and if that's okay, then all of the child or daughter or whatnot calibrations are then accepted kind of by default, or as a much simpler discussion extension. And often that's in making sure the after treatment's big enough to handle the high power, or the transients, or thermal durability, or those kinds of things. But we see in the off-road that there's some challenging situations that are analogous to the low load situations we were talking about yesterday, where someone bought a large engine and then did all this investment and then isn't using it. Or it has a large idle kind of component to the duty cycle, and it may not be so much the average duty cycle, but the duration of these really low load events that allow some things to happen in the after treatment that make it difficult to operate in the short term or in the long term. And some of these we've seen it in are in situations where you have two pieces of equipment that meet each other. And so queuing theory tells you that you can't have everybody moving at the same rate at the same time. Somebody's going to get to wait. And so whether it's the trucks or the haul equipment or whatnot that's waiting for the loader, or if it's some kind of RTG or crane or lifter or something that's waiting for the vehicles that will carry the goods away, that there can be some of these long wait cycles, and then all of a sudden it does a short heavy operation, then it goes back to the waiting. Another example is sort of drill equipment or oil well service equipment kind of applications, where there may be a very heavy drilling operation, and then there may be a secondary kind of PTO operation to while they're swapping things out, or they're doing some of these water drilling rigs have like 36-hour pumping tests. So the same engine that drilled the big deep hole is running very close to idle to just do a demonstration test on the well's flow rate. So these kind of things can allow hydrocarbons to build up on catalysts and have kind of coking issues and these kinds of things. If an engine that was intended to work hard gets kind of put into one of these applications, it requires some calibration. So this low load durability and what does it actually do in the field is an area we're very interested in, and having equipment out there that works for the diversity of applications. And sometimes it's not a big tweak to be able to recognize some of these situations and keep a little heat in the system, or periodically do something that takes care of it. But as engineers, we sort of expect our equipment to be used, and so it's a use case that we tend to hear about from customers, which probably means that all the rest of the customers it's working pretty well for. We have a project looking at low NOx at Southwest Research, and part of that is looking at trying to control NOx in a low load environment. So that'll be interesting to look at some of the short term effects of low load on NOx control and what we can do technically with diesel engines. So I had just a couple of questions we're thinking about, ideas we're thinking about, issues we're thinking about at the Air Resources Board. That we saw some presentations this morning on the different emission standards and approaches people are taking to it. And so we have some interest in really understanding the life cycle behavior of some of the non-DPF style emission systems versus the DPF incorporated solutions. And as the rest of the package evolves, do we still get the same kind of control and environmental protection that they gave initially? We also have seen some interesting things in our warranty reporting rates where we see suppliers selling into all the diesel markets, and in on-road we see fairly high warranty rates on certain parts, and then there's sort of much lower warranty rates reported in the off-road, and we're not sure why a more severe duty kind of situation may result in suddenly increased durability. But we have run into situations where there's a power plant is on some kind of a very expensive piece of equipment, and the fleet operator's like, yeah, I just stick another one in there. I don't call it in. We have 3 replacements on the shelf, and we can't stop, kind of thing. So there's some we're interested in durable solutions, and if there are issues, we would like to know about them to be able to help address them. So if there are applications there where we rely on the warranty reporting information to kind of direct some of our activity, but if we're not getting that information, we can't help people on that. And so we're interested in what the potential is for making sure that these systems operate well across the range of operating conditions and at good emission control. I wanted to talk just a little bit about emission heavy-duty in-use compliance. Last year we started our on-road pilot project in-house, so we're doing NTE testing over the road of semi-trucks, and this year we started full test groups on that, and then we have interest in moving into looking at some of the off-road performance. And so, I'm not sure exactly when that's going to start up. It's going to kind of be on a available resources basis. But the off-road engines, when they certify, have to make an attestament that they meet NTE requirements. And so we're interested in sort of looking at some of that. And we've been finding some interesting stuff in the on-road investigations we've been doing, and we'll be discussing that with the respective manufacturers on an ongoing basis. But we are interested in what things are doing in the field, what the actual in-use emissions are, how our inventory is actually, how accurate that is. I want to put in a plug for the low NOx work we're doing on-road. That we have a workshop next week where we're talking about that, and part of that is, as Dan Carter was talking about, the NTE in-use regulation could use some updating. We have some line haul data where 5% of the activity and maybe 9% of the NOx is subject to the rule, and these are on freeway routes running from LA to Palm Springs and back, and LA up to Hesperia and back. These are on the way to Vegas, on the way to Phoenix. These are goods movement freeway routes with significant grades, and we're seeing very little coverage. So we're interested in an in-use tool that looks at a given piece of equipment, what that piece of equipment or vehicle's impact is. So we invite people to this will be webcast, and to participate in our process there. So we see that the off-road is a challenging sector to deliver products in, and to understand the diversity and duty cycle variability. We're seeing very exciting developments in the diesel technology. We're pushing it on the on-road side right now, but we're interested in seeing some of those improvements migrate onto the off-road. And in the near term, we're pushing incentive funding, trying to get cleaner technologies and advanced technologies into the marketplace, and doing some testing to sort of understand what we think about the current Tier 4 implementations and where we might go from there. Thank you.